Welcome to the Salt Lake Azure User Group. I'm your host, Troy Fillerup, and hopefully we have a good time tonight. So a couple of things that I like to do. So, well, first of all, let me see if I can. Okay, so let me just do a quick intro. My name is Troy Fillerup, and that is my real last name. I sometimes have to qualify that because people think I'm messing with them. I'm the Technology Solutions Manager here at STG. So the building here is Software Technology Group. I've been with STG for 21 years, and I finally made my way up to management, so I feel pretty good about myself now. Except now I'm management, and nobody wants that, right? But I'm the co-founder of the Salt Lake Azure Group. My other co-founder, a guy by the name of Brian Foster, has since moved on to other things. So right now I'm the only organizer of the group. I'm an old man, as is evident by my silver demeanor. And I've been a .NET developer. I started my development career back before most of you were probably born, with a software product called VB3, Visual Basic 3, long time ago. My first computer was actually a VIC-20 from a company called Commodore that doesn't even exist anymore. And I wrote stuff in BASIC. So I've been around a long time. Once I got into Visual Basic, though, I kind of stuck around in the Microsoft ecosystem. I went up to VB.NET. Once C# came out, I abandoned Visual Basic completely to never look back. And now I'm a C# developer. A few years ago, I started working in the cloud, specifically Azure, because again, Microsoft, right? And for the last, 8 or 9 years, I've been cloud. So now my main job at STG, besides being Technology Solutions Manager, is to be a solutions architect and a cloud architect in the Azure ecosystem. So that's a little bit about me. So there's a couple of things that I like to do before I launch into the actual content. So the first thing I like to do is I've started doing this thing called lightning talks. And it's the opportunity for one of you to get up and give a quick 5-minute talk or chat about something that you've learned recently or that you're interested in. And by no means is it compulsory, but I want to give people the chance. If there's anything that you wanted to talk about or anything that you're interested in, this is your opportunity to get up and talk in front of a small group. Anybody interested? Okay, now wait. Okay, hold on. One at a time, please. No. All right, no, that's fine. I do this every time. So if you do run into something that you're interested in or that you find cool, this is a good forum to maybe get up in front of a crowd. So if you don't want to, fine. Can it be anything or just Azure? Whatever you want. If you want to talk about your rose garden, then no. Typically, we try to keep it technology focused. It doesn't have to be Azure. Mike.
I do have one. I was surprised in Azure DevOps there's actually a ton of built-in reporting tools and great functionality. I'm not basically sort of other people's work, but actually pulling and querying.
Yeah.
There's a ton of built-in functionality that I think was.
That's cool. You know what? That sounds like a good topic for a presentation some other month. So I'll hit you up after that. And along those lines, Azure, you can build extensions for Azure DevOps. I don't know if anybody uses Azure DevOps. If you don't, you should. It's way better than Jira and Jenkins and all that other useless crap.
Should I use it over GitHub Actions? Because I've been like
debating
which one.
In my opinion, I prefer it over GitHub Actions. I've used both, and I use both quite a bit. I prefer it over GitHub Actions. I like the UI better. I like the integration with your work items, with you got your pipelines, you've got your Git, you've got your wiki, you've got everything right there inside of one great big package. Personally, I'm not a huge fan of GitHub Actions. I mean, they do what you need, but I really like Azure DevOps. Mike? Yeah. Yeah, and we'll do another presentation on Azure DevOps. I talk about Azure DevOps till I'm blue in the face. Caden here knows. I love Azure DevOps, and there's a lot of stuff you can do in there. So we'll do another presentation 1 month on Azure DevOps and everything you can do there. So good question, thank you. All right. Any questions about my old man status? Nobody cares? All right, we'll move on then. 20. I hit my 35th anniversary of my 20th birthday recently. So. All right. Tech tips. So the other thing that I like to do, besides the lightning talks that very rarely happen, I like to give a little tech tip that's kind of off topic from the main meat of the thing. But it's something that I have learned recently that I think is really cool, and I just like to share it. So I'm a .NET developer from way back, right? And one of the things that we always have to do is create REST endpoints for grabbing data from entities, right? So you build a database, you need to get your users, you need to get your products, whatever. And there's a lot of hand coding that you can do that. Here's my Git endpoint. Here's my minimal API for posting, for putting, for whatever. That's a great way to do it, right? But there's this cool little tool called ASP.NET Code Generator. And what we have, I'm going to show you. So what we have here is I have this .NET application. And I've got my shared project, I've got my services project, and this services project has some endpoints. So I have role endpoints, user endpoints, based on these classes that I built, right? So I've got this product. So I had to add a new product entity. So I'm using Entity Framework, right, obviously. So I have this product entity, and I need to write the endpoints to get products, post products, put products, delete products, whatever I need to do in products. So I can go in and I can write all of these endpoints. So if we go look at the user endpoints, I've got, so I'm using minimal API. If you're not familiar with minimal API, don't worry about it. This is just a one way other than controllers to set up your APIs. So I've set up one to do a get. That's just a slash, so that if you just call a get, it'll return all the users. So that's what this does. I've got my get to return by ID. I've got a put to update it. And you can see this uses all the latest ways of using Entity Framework. So this execute update async is the way that they recommend you do updates in Entity Framework. Right? Back in the old days, you used to get the entity, modify it, put it back, update or save changes async. You don't need to do that anymore with this. Same with delete, right? So you come down here, this is my delete. You've got to execute delete async now. Okay, so this is all the latest stuff, but I don't want to have to go in here and type all this out. So what I can do now is I can come into PowerShell, and who doesn't love PowerShell? I love PowerShell. I'm a command line junkie, which is weird, right? Because we got all these graphical, no way, man. PowerShell and command line is the way to go. But anyway, what we want to do is we want to type this command. First, we need to install the plugin for the ASP.NET Code Generator, right? And you can go on Microsoft Learn to figure out how to do that. But then all you do this is you type .NET ASP.NET Code Generator. This minimal API tells it what you're building. You can build Blazor forms based on your entities. You can build, you can stub out authentication for stuff. There's a whole bunch of things that you can do with this code generator that just builds it for you. Then you pass in the data context, you pass in the name of the class that you want these endpoints to be put into. You pass in the name of the class, of the entity, and then you give it an output directory. So we're going to run this, and everybody cross your fingers, because you know how live demos can be. Let's see what happens. And it does take a second. Okay, so now it's done. So now let's go look at our project. Now that we got that done, now you can see I've got this product endpoints class here. If I go into that, here's all of the API endpoints for that product. Now, these are very generic, right? They're just a foundation to build off of. But now that puts in a lot of that boilerplate code so that you don't have to go put it in yourself. And it also comes in here and it does this map product endpoints in your startup. So now you can just run this and you have all your APIs built for that entity. So cool little thing. And the reason that I found that is I'm working on some scripts that will build out an entire project for you. And this is one of the things that I wanted, is to have it create all of your endpoints for you too based on your entities. So cool little tool. Check that out. This is the .NET ASP.NET Code Generator. Any questions about that? Okay. Awesome. Well, let's get into what we came here to talk about. Ways of hosting apps in Azure. There are more than one way to host apps in Azure. Who knows how many ways there are to host apps in Azure? I don't really know either, honestly. And I'm not going to cover them all today because there's all kinds of things in there. But we're going to go over a lot of them, the major ones, and I'm going to talk about the one that I like the most. I've kind of fallen in love with this one, and I use it a lot, and we'll talk about that. But there's essentially 3 ways to host apps in Azure, right? And most resources in any cloud falls into one of these categories, except for SaaS. SaaS is different. But we have IaaS, which is, what does IaaS stand for?
Infrastructure as a service.
Boom, got it. Infrastructure as a service. We have PaaS, platform as a service. We have static. What does that stand for? Nothing, static, right? So we have those 3 ways of hosting apps in Azure. Now, IaaS is really good if you need total control of everything. I steer away from IaaS as much as possible. If you don't have to have IaaS, it's better not to use IaaS because there's a lot of pluses, but there's a ton of negatives too. And we'll talk a little bit about some of those. Virtual machines. Boom. And we're going to talk about that next. Absolutely. Virtual machines are IaaS, right? So let's go to the next thing. So these are the ones that we're going to talk about today. Number 1 is virtual machines. Then we're going to talk about Kubernetes through AKS, Azure Container Apps, Azure Container Instances, Azure Web Apps, Function Apps, Static Web Apps, and Storage Account Static Websites. Anybody have a guess as to which my favorite one is? Container apps, yes, exactly. I love container apps, and there's a lot of reasons, and we'll talk about those. Yeah. All right, so let's go through. So the first one is virtual machines. So virtual machines is the IaaS way of hosting apps in Azure. And essentially, it's like if you're hosting something in Hyper-V or VirtualBox, right? Or actually in an enterprise, it would probably be VMware. It's just an entire machine being virtualized on another machine. So you have total control over the operating system. You have total control over the applications running on it. You have total control of the entire computer. That's the plus side of it. The negative side of it is that you have to have total control over the machine. You have to have total control over the OS, right? So the good things are also the bad things. If you need to update your OS, you're responsible for that. If you have to update your applications, you're responsible for that. If you need to patch something, you're responsible for that. So in the IaaS side of things, the cloud provider only worries about the infrastructure. It gives you the hardware to run the VM on, but that's where their responsibility ends, okay? Now, in Azure and in any cloud platform, there's a lot of tools that they provide to make patch management easier, update management, security. I mean, there's a lot of stuff there. But the problem with VMs is that you have to control the whole thing. And VMs are expensive. They're big, they're fat, and they're expensive. Sometimes you have to use a VM. If you're taking an application from on-prem that runs in a VM and it's 10 years old, you may have to keep it in a VM. Now you can lift and shift that VM into Azure, right? But you may have to keep that VM because that application won't run anywhere else. Let's say you have an old website that runs in IIS, right? And it has to run in IIS. It uses IIS stuff. Well, you can run that in Azure, but you're going to have to put that into a VM, okay? Now, the ideal situation would be to shift it up into a VM and then through time, re-architect that application to be cloud native and take advantage of the cloud native features that we're going to talk about next. And you can scale virtual machines, but they don't scale quite as easily. So yeah, I mean, VMs are great, but unless you absolutely need a VM, I tend to steer away from them, mainly because of the management and the cost. VMs are always more expensive. Now, hold on. Let me edit my thing real quick. Hold on. You're right, cost is a con. Now, there are ways to mitigate cost with any of these. One of the ways to mitigate cost in a VM, well, there's a couple. You can have auto shutdown. So a lot of people use VMs for developer machines, right? You'll install Visual Studio, VS Code, whatever the Java stuff is, Eclipse, I don't know, that other language that people use. You install all that on a VM, and then your developers can use the VM, right? But your developers don't work 24 hours a day usually, you know, and so you can have it auto shut down. So at 5 o'clock at night, you have the VM turn off, and then while it's shut down, you don't pay for the compute on the VM, right? So that's one way to mitigate costs. Another way with VMs, a lot of people will use VMs to host batch processes, but the batch processes maybe run, you know, once a month and maybe aren't time critical even when they do run. So you can do what's called spot instances in VMs, where if you turn on spot instances, what that means is that if Azure gets really busy and needs more resources, they will shut your VM down, take those resources and use it for something else. Until they have the free capacity, then they'll give you back and fire up your VM again. So really good way to save a lot of money, but you wouldn't want to do that for your production website, right? Because you don't want it to go down who knows when, and you don't know. It'll go down whenever they think they need to take it down. Yeah.
So you just said whatever they think they need to take it down. Is that somebody external to you?
That's
or is it
Azure.
based on all the different things you're running?
It's Azure. If Azure thinks that it needs more resources, it will take it from you.
Wow.
So yeah.
So the other side of that is you can build your application, you can absolutely use scale.
Yes, you can absolutely use scale sets for sure. Yep. And that's the thing. But one of the use cases for VMs is to lift and shift existing apps. But you're absolutely right. If you can design it to be resilient in that way, then you can definitely do that. Now, there's better ways. If you're building cloud native, there's other ways to do that, which would accomplish the same purpose and not have those downfalls. But yeah, you could absolutely do that. Because VMs have this concept of scale sets that let you scale up, so it'll add extra instances of the VM, it'll load balance between them and stuff like that. It's a little slower. One of these things is it's a slower scaling, because what it has to do is it has to fire up an entire new VM, right? It has to load the entire operating system. It has to bootstrap everything that, I mean, have you ever loaded Windows Server 2012? I mean, it takes a while to come up, right? So when you have VM scale sets and it has to bring up another VM, it takes a while to do that because it has to boot up the whole thing. And so, so we're going to talk about, any other questions on VMs before we move on? Okay. We're unfortunately not going to get very deep into any one of these, but throughout the next few months, I'm hoping to have a deep dive session on each one of these, right? So today I'm going to kind of give an overview of all the different things. We will then, throughout the next few months, go into a deep dive of one or two at a time and learn a little bit deeper about them. And virtual machines, super important resource in Azure. Don't take away from this that VMs are useless, because they're not. They're super important. And so, so we'll dive deep into those and some of the things that you can do with VMs. There's just other ways to do things. If you don't need the full power of VM, there's other ways to do that. All right, let's see what's next. Azure Kubernetes service. I'm going to be completely honest with you. This is not my area of expertise. AKS is something that I don't use a lot because I like to do things in a different way. AKS, who's a Kubernetes expert here? Who's used Kubernetes before? Okay. Is it fun to use? Do you like it? Let me tell you something. If you've never used Kubernetes, in all honesty, Kubernetes is super, super powerful. But what did Uncle Ben say? With great power comes great responsibility, right? Kubernetes is not for the faint of heart. You really need to know what's going on. It takes a lot more effort to manage, and you really have to become an expert in Kubernetes. Now, Kubernetes is amazing, right? It lets you run things at massive scale. It has all kinds of self-healing capabilities. It does all kinds of stuff that is just amazing, but you have to really know what you're doing to get in there and use Kubernetes. And AKS kind of abstracts some of that stuff out for you. So AKS essentially, I don't have that graphic here, but Azure provides the control plane for Kubernetes for free, so that you don't have to worry about that part, and then you just have to worry about your nodes and your pods and your sidecars and your everything else that Kubernetes has. So it's a little easier to use than maybe on-prem Kubernetes or stuff like that, but it's still not something that you can just pick up in a day and go run with. Again, super powerful, super good for scale. If you're running a application that is getting 1 million hits a minute, Kubernetes is a great option for that because of the scalability, of the resilience, and all that kind of stuff. And we'll dive into Kubernetes, but before we do a really deep dive session on Kubernetes, I have to go learn it better. So we're going to put that one back a little ways. So, because we have this amazing thing called Azure Container Apps. And Azure Container Apps are my favorite for a couple of reasons. Who uses containers? Okay, most people use containers. Containers are amazing, right? I mean, the theory, so back when I was a young developer, we always gave the excuse of, well, it works on my machine. I don't know why it won't work on your machine. It's fine over here, right? We used to do that all the time. Containers attempts to take that excuse away from us, which I guess that's not a good thing, maybe. But anyway, so if you can get it to work in a container on your machine, that container should theoretically work wherever you put it, whether it's in AKS or Azure Container Apps or Azure Container Instances or Docker Desktop, wherever you want to put that container and run it, it should run the same no matter where it is, right? So Azure Container Apps, essentially it's Kubernetes in the background, but they extract all the tough stuff of Kubernetes away from you. So that's good and bad because you don't have to worry about all the hard stuff about Kubernetes, but then you don't get all of the power and control of Kubernetes either, right? They try to extract all that out so that you only get the stuff that you need to run your apps. And it's super simple to run your microservices, your websites, all that stuff is really easy to put into Azure Container Apps. So essentially you have, and we'll do some demos. I'll show you some of these things when we get into it. But you have an Azure Container Apps environment, and then you can put multiple apps inside there. And then those apps can communicate with each other, right? So there's a sidecar called Dapper, and we're going to do a thing on Dapper too, because it's not the database ORM, it's a different Dapper. We'll do a thing on Dapper because it's really cool, but it does a lot of things for your microservices. ACA has built-in support for Dapper. And also inside of that Azure Container Apps environment, you can specify the ingress capabilities of each app. So let's say you have your web app, and then you have several API microservices that you need your app to talk to. Well, you need people to be able to get into your web app, right, from the outside. You want, if they can't, then what's the point of even having it, right? So you allow external ingress to your app, but then you turn off ingress to all of your microservices except from inside the Azure Container environment. So what that means is that your web app can call out to those APIs, but nobody from the outside can reach those APIs. So it helps with security. It helps tighten up that security perimeter. And then obviously you can throw it into a virtual network and put all of that kind of stuff around it as well. But it's a really easy way to make sure that only your web app and only the other APIs can access things inside of that Azure Container Apps environment. Another pro of Azure Container Apps is the scaling. So the same with AKS. So in Kubernetes, there's this concept of a Keta scaler, and there's different parameters that you can scale things on. You can scale them based on HTTP requests. So if I start getting more than this number of HTTP requests, let's spawn up another instance of that, right? And you can spawn up multiple instances. You can also do it based on CPU, based on memory, things like that. If you scale your apps based on HTTP requests in Azure Container Apps, they can then scale down to 0. What that means is that you don't pay for that while it's scaled to 0. So if you have an application that's only used maybe during the day, maybe you have an internal app that, after 5 o'clock, nobody touches it. So why sit there and run it, right? Well, that container app will scale itself down to 0, and then when somebody goes to hit it again, it'll spin it back up, and then you start getting charged again. The downside of that, does anybody know what the downside of that is? Cold starts. That's exactly right. It does do a cold start, right? So after it scales to 0, I've seen it take upwards of 30 seconds to spin up. Usually not that long, but it could take that long. Now, one of the things that I use that scale to 0 for a lot is when I deploy apps, I usually deploy them to different environments, right? You deploy them to dev, test everything, make sure it works, deploy it to stage, deploy it to UAT. I mean, you test the crap out of it along the way before you go to production, right? You should. Right? You know what? I saw a beam from the most interesting man alive, the Dos Equis guy. He says, I don't often test my code, but when I do it in production. Nice. Love it. So that's an option. You can do that, right? But ideally, you maybe test it first before you go to production. But the reason I brought that up is because when I go to dev, I scale it down to 0. I don't want to spend a lot of money in my dev environment. So I have it scaled to 0. As a developer, I don't mind if it takes a few seconds to spin up when I go to test it, right? And so typically I've seen it, if it doesn't get any activity for about 5 minutes, it'll scale it down to 0. But when you go to set it up, you set it up what's the minimum instances you want and what's the maximum. And so if you set it to 0, it'll scale. If you set it to 1, then it'll never scale to 0 and you won't have that cold start issue. But it's running all the time. And the way that container apps work is you pay for number of requests and CPU seconds or something like that. I'm not 100%. I can't remember. And we'll look at some of this stuff when we get into the portal. But okay, so the cons, like we said, you don't have quite as much control as you do with AKS. I mean, unless you really, really need that, it's not a big deal. And there are fewer features. So Azure Container Apps are one of the newer ways of hosting apps in Azure. And last time I checked, and I don't think this has changed, but you can only host Linux containers. You can't host Windows containers. Who wants to host Windows containers anyway, right? Linux is the future. 10 years ago, that would have made me sick, but I actually like Linux now. So Azure Container Apps, really great way to host apps. Okay, this is just a little graphic. See, I like these enough that I actually have a second slide for them, so that tells you something. So you can use it for public API endpoints. So one of the things that a lot of people use Azure Functions for, and we'll talk about those in a minute, is HTTP endpoints for APIs, right? I've actually started moving my API endpoints to Azure Container Apps because I like them so much. I still like Azure Functions. There's a lot of things you can do with Azure Functions. We'll talk about that in a minute. Background processing. So you can just have a container that just runs and does stuff. Event-driven processing. So this is one that, yeah, you can do in Azure. I prefer to do something like this in an Azure function, but you could have it read from a service bus or an event hub or an event grid, things like that, and process data. And then microservices. Here's that Dapper. So this is how they spell it, D-A-P-R. And we'll get into that another time. Any questions on that? Okay. Azure Container Instances. Well, this is another way to run containers. So that's 3 so far. 3 ways to run containers. Well, no, 4, because you can run containers on a VM, right? So, yeah. So Azure Container Instances are really good for single containers, single apps. You wouldn't, like in an Azure Container App, you can have your web app and a bunch of microservices and have them all work together. Azure Container Instances are really designed for single apps that just need to be deployed into a container. They don't auto-scale, so there's no auto-scaling at all. You can manually scale them if you want to, but there's no auto-scale. There's very limited orchestration. If you just have a workload that maybe needs to run once a month, or you don't want to throw it into a VM, you can containerize it. An Azure Container Instance is a good way to do that. It's easy to deploy these, but they are pretty limited in what they can do. However, in an Azure Container Instance, you can run Windows containers. So if for some reason you need to run a Windows container, and I was just teasing before, there are valid reasons for running Windows containers. If you need to run a Windows container, ACI is a way that you can do that. All right. Azure Web Apps. So this has been the way to run apps in Azure since time immemorial, right? Azure Web Apps have been around for a long time. And guess what you can run in Azure Web Apps? Containers. Yeah, so that's 5. Yeah, you can actually run containers in Azure Web Apps too, right? But Azure Web Apps are super cool. They're a completely platform as a service way of running apps, right? So you can just deploy your app there and don't have to worry about anything with that app. It'll just run. Now, there's a lot of stuff you can do. You can set up auto scaling to go up and down, right? That's what auto scaling is. You can also scale it out. So you can put it on a pretty beefy Azure Web App in case you have applications that need more CPU horsepower, not just more instances of it running, right? And then you could even scale that up. So you could have, a P2V1 tier that has 50 instances running, right? It gets expensive, but if you need that kind of horsepower, it's because you're making tons of money and you can afford it, right? So that's the trade-off there. So the pros is it's fully managed web hosting, and you can host all kinds of stuff in an Azure Web App. You can host Node, Python, obviously .NET, and all kinds of stuff in an Azure Web App. Supports multiple languages and frameworks. Look at that. It is a little bit less flexible than some of the container options, but most of the time you may not need that kind of flexibility. And Azure Web Apps are just a super easy way. Now, one of the downsides of Azure Web Apps is they're not really portable between clouds, right? So you have your Azure Web App. If you need to take that and move it into AWS, right, you're going to have to redeploy it into whatever the AWS equivalent of Azure Web Apps is. If you have a container and you need to put that into AWS, you just go to AWS, say, hey, grab the image from here and spin up that container. You're done, right? So containers make it really portable to move around. Azure Web Apps and the rest of the things we're going to talk about are not as portable because they're Azure native resources, right? You absolutely could. Yep. And then you can take that same container and put it somewhere else. Yep. You sure could do that for sure.
Cost difference between this and the other options?
Yeah, there is, and I don't know the exact, but if you've never been to the Azure pricing calculator, that gives you a really good idea of what everything costs. So and we'll take a look at this, but with Azure Web Apps, you kind of set your tier of what you want, and it shows you this has this much CPU, this much memory, all that kind of stuff. With Azure Container Apps, you go in and you say how much CPU do you want and how much memory do you want. So it's a little bit different way of setting it up. It sounds the same, but it's a little bit different, and we'll look at that when we look at the portal. But yeah, and if you haven't looked at Azure pricing calculator, it'll tell you how much things cost. And that's another thing with these is that there is a free tier. You can host apps in an Azure Web App in a free tier, and it won't cost you a dime ever. There's a downside. Number one, it's all shared resources, right? So you're actually sharing compute with everybody else that has their apps in the free tier, right? So you're going to have really crappy performance. It's great for testing stuff and maybe trying stuff out. Anything beyond that, it's not good. So you have really crappy performance, and you only get a limited amount of compute per month too. So it's not like you can just run a website on 24 hours a day. You get 500 minutes, I think, a month or something like that. And then it just won't work until the next month. So there's a free tier. With Azure Container Apps, there is a free allotment as well. You get 2 million HTTP requests and like 400,000 CPU byte minutes per blah blah blah, something like that. Anyway, there's a free allotment for Azure Container Apps as well. But what I found, if I remember correctly, when I tried it, if you keep it running 24/7, I think that free allotment is good for about 32 hours, something like that. So, you know, it's something to help out a little bit, but it's not, I wouldn't count on that to save tons of money. The next thing is Azure Function Apps. So Azure Function Apps are also super cool. These are a completely serverless way of hosting apps. And you deploy your Azure Function App and it pretty much handles everything for you. You don't really need to do hardly anything with them. They scale themselves automatically up and down. They you can run .NET, you can run PowerShell, you can run JavaScript, you can run Python. There's a whole bunch of different languages that they support natively. You pay per execution. So you only pay for the number of seconds that function runs in a month. So it's one of the options is to pay consumption based, right? Now there are other options. You can have it be in a premium tier that is not consumption based. You can put it in an app service plan, but then you have to pay the monthly fee of the app service plan. Does anybody know what would be the advantage of putting it in an app service plan rather than using consumption? Cold start. That's right. Functions have the same problem as the Azure Container Apps we talked about. If they sit idle, they go cold, and then they have a cold start. Now there are ways to mitigate that. There are things you can do to mitigate cold starts and to make them faster, and we can talk about those in another session. But
So did you say Azure Function?
so Azure Functions also are free for the first 1 million executions every month.
Oh.
Yeah, and so if you don't need more than 1 million hits to your API, Azure Function Apps could be totally free. And they are incredibly cost effective. Does anybody know who Scott Hanselman is? So Scott Hanselman is like the .NET god at Microsoft, right? He's like VP of something or other. I'm not sure, but he's super smart. And I went to a talk by him once, and he was talking about, he had a client that did, that called in and said, hey, I think our Azure bill might be wrong. We only got charged a couple of $100 for this Azure function last month, and we had billions of executions. And they started digging into it, and they're like, well, yeah, that's right. That's how much it costs. So you can run a lot of functions for really cheap. Because you pay for how many calls you get plus how many seconds it runs. So Azure Functions are really designed for really short workloads. An API endpoint is a good example. You call into it, it goes, gets some data from a database, returns it back, and then it's done. And that's all it does. One of the downsides, well, right here, limited to short running tasks. One of the downsides of Azure Functions is they have a hard limit of 5, or you can increase it to 10 minutes running time. So if you have a process that takes longer than 10 minutes to run, Azure Functions is not the way to go, probably. And what happens is the exact length is non-deterministic. So it could be 5 minutes and 10 seconds. It could be 4 minutes and 40 seconds. You don't really know. And then it will just kill it. So if you have something running, it doesn't care. It'll just kill it. So really good for short running tasks. Now, there is this concept of Azure durable functions that you can do longer running things. And we can talk about durable functions another day. But Azure Functions in general are for short things.
Is that 5 minutes of all your time, or 5 minutes of like you getting access to the CPU?
That's 5 minutes of you running that function. Once you hit that function and it starts executing, you have 5 minutes to finish. Now, if you call it again, it fires up another instance of the function. See, that's the beauty of Azure Functions, is they're auto-scaling. If you have somebody call in, it'll fire up an Azure function. You have somebody else call in, it'll fire up another one. Somebody else call in, it'll fire up another one. You have 50 people calling at the exact same time, it'll fire up 50 instances of your Azure function. And that's the automatic scaling that you get. And I think you get up to 400 running instances at a time, which isn't a problem, right? Because typically, again, it's short. it shouldn't be longer than 30 seconds, maybe a minute, and then it goes away, and then it's ready to serve somebody else. One of the things that may hit it a little hard is, so with Azure Functions, you've got this concept of a trigger. And a trigger is the way that the Azure function gets started. So one of the triggers that you have is an HTTP trigger, which means that you make an HTTP call to that function, and that kicks it off, and it goes and does something and returns. A REST API, right? It's an HTTP trigger. You also have a service bus trigger. You have an event hub trigger. You have a timer trigger. So if you have a service bus trigger on an Azure function, and you're dumping 10,000 messages into the service bus all at once, then it's going to take a while for those 400 instances of the function to chew through all of those messages in the service bus. But it will. I mean, it'll just keep all 400 of those running until it's done, and then it'll just close them all down, and you're only paying for the ones that ran. So, any other questions on Azure Functions? If you're familiar with AWS, their corollary over there is AWS Lambdas. They're similar. Oh, absolutely. Oh, yeah, absolutely. Azure Functions is super cool. And I've actually done talks before, and there's a lot of content there. So, and we'll actually go in and look at a little bit of it in the portal and talk about a couple of the things today. All right. Azure Static Web Apps. This is one of the, it has been around for a little while, but I haven't done a ton with this. But essentially what this is it's just a way to serve up static web pages, right? There's no server-side capability here, so it's not like running in an Azure web app where you can run code on the back end. This pretty much serves up JavaScript and HTML, right? Now, there is a way to integrate an Azure function to your static web app. So your static web apps can call into Azure functions that are defined in your static web app. So you do have a little bit of stuff there, but it's pretty much for if you have a SPA, like a Blazor WASM app, or a React app, or an Angular app, you can host that in an Azure Static Web App, and this is a good, really cheap way to do it. Now, it's a little bit different to deploy into an Azure Static Web App. You actually have to connect it to a CI/CD. You can't like do a deployment from Visual Studio into a static web app. That I found anyway. It's kind of weird. You kind of have to do it through CI/CD. You have to hook up your Azure Static Web App to a repo anyway. And so it's a little weird. Now there is a command line. It's called AZ Static Web App, I think. It's another plugin for the Azure CLI that lets you push stuff into an Azure web app from the command line, or a static web app from the command line. But typically you just commit something to your repo and it will magically show up in your static web app if you set it up that way. Yeah, so limited to static content, no server-side logic. Now this does also integrate with Azure Front Door and Azure CDN, which is great, right? For static web apps, the CDN is awesome because it will help to make your content delivered on the network, right? Get that content delivered. So you can integrate it with Azure CDN so that you have better performance worldwide for your static web app, right? If you're hosting your stuff in West US 3, we have customers in Europe, you don't want your customers in Europe to have to go to West US 3 to get your content. So using Azure CDN, it will push that out into the edge, and then you can have your people in Europe get it from a server in Europe. All right. Any questions on static web apps? Okay. A little bit more limited, right?
The Azure functions that are defined in that, though, they can do server-side.
Yes, absolutely. Yep. So you do kind of have some server-side capabilities, but you have to reach out to an Azure function to do that. Yeah. And you have to set those Azure functions up in the static web app resource in Azure. Okay. All right. The last one is storage account static websites. I know this sounds the same as the other one, but it's not. This is probably the cheapest way to host websites in Azure. Essentially, all you're doing is you're putting your web files in a storage account and opening that up to people to get. So this is 100% pure static HTML and JavaScript. There's no Azure function connection. This is a storage account, It's like hosting it on the file system of your hard drive and then going there with your browser, right? That's pretty much what it is. But you can host HTML and JavaScript. So you can host a React app in here. If it's all contained and all static, you can just host it in here. And I actually use this quite a bit so I use a language called Structurizer to create architectural diagrams for my cloud architectures. And they're text files, but you can render them into diagrams. And so when I put them into my repo, I have a pipeline that will take those, render the diagrams, and put them into an Azure Storage account static website to make them available to the customer. So there's no backend, there's no nothing. It's just static content. This works very well for that, and it's super cheap because you're just paying for the storage essentially, and a little bit of ingress. Well, actually not ingress. You're paying for a little bit of egress of the data. So, but you're not going to host a great big Amazon web application in storage account static websites. Well, you wouldn't host Amazon anyway. This is Azure for crying out loud, right? All right, let's take a look at this. So this is kind of a decision tree. When you're trying to decide, well, good grief, we just talked about 12 different ways to host apps in Azure. What do I use? This is kind of a decision tree to help you decide how to do that. So, and this is on Microsoft Learn. It's just up there. So you go to start. You say, okay, I need to start. Do you want to migrate or build new? Well, we want to build new. We never want to migrate anything. Everything needs to be rewritten from scratch, right? Isn't that what developers do? Hell yeah. Yes, we want to build new. Do you require full control? Yes, you go to a virtual machine. If you don't need a full control, is this an HPC workload? And this is one we didn't talk about, Azure Batch. If you have the need for high performance computing, like if you're taking videos and rendering them to another format, or anything that you need supercomputer level power for, that's HPC, high performance computing. You would put that into Azure Batch. So do you need HPC? If so, put it into Azure Batch. Azure Batch, I've never used Azure Batch. I've never had a need to do that, and we probably won't go into a deep dive on that one, because that's one of those things that, how do you play around with that, right? I mean, anyway. No, you don't. Are you using Spring Boot apps? No, this is another one that we didn't talk about. Does anybody know what Spring Boot is? Okay, it's a Java thing, right? That's why nobody here knows what it is. Because, it's a Java thing. Now, the problem with Azure Spring Apps is they were announced that they're being retired. In fact, a couple of tiers were retired at the end of last month, and the rest of the tiers are going to be retired in 2026, which sounds like a long ways away, but if you're having to retool your apps, that's a little closer than you think. So if anybody here is using Azure Spring Apps, you need to get off of that. And you may be asking yourself, well, what's the other option? Anybody know what the other option would be to move into? Azure Container Apps. Yeah. Azure Container Apps. Okay, no, you don't need that. Is it an event-driven workload with short-lived processes? Well, Azure Functions, perfect for that, right? Managed web hosting platform and features, you do need that, so you do Azure App Service. Then you go down to Azure Container Instance. Azure Service Fabric, that's another one we didn't talk about. And we will probably do a deep dive on that. That one's kind of, you don't see it as much anymore, but it's still there. It's kind of like, it's good for running your older .NET stuff on. I mean, if you've got new stuff, you're going to put it into Kubernetes or ACA or something like that. But if you do need, like, if you have framework 4.8 or 4.7 or something like that, and you need that kind of orchestration, then Service Fabric would work for that. Are you using Red Hat OpenShift? The answer to that is almost always no. But I do have some clients that do use Red Hat OpenShift, and that's another one we didn't talk about. But do you need access to the Kubernetes API? If yes, then you go to AKS. If no, you go to Azure Container Apps. So this is a pretty cool little graph. If it's something that, if you're trying to decide where to put your app, like I said, 9 times out of 10, you're going to use either AKS, ACA, or Azure Functions, and maybe Azure App Service. Those are like the big ones. There are reasons to use the others, and you have to make that decision yourself. So, any questions on this? There's a lot there. It's a lot to look at. All right, so let's just take a look at the portal a little bit. I love playing around in the portal, but I love even more using the Azure CLI. So we're not going to do that today. All right, so let's just take a look at a couple of things. So you can see that I've got a lot of different resources in here. I'm going to, people still see that? Everybody still see that okay? All right. So I have this resource group, RG Slag Demo. I just put a whole bunch of different resources in here. They don't really do a lot, but I just wanted to show the difference between them. So let's first take a look at an Azure container instance. So this is an Azure container instance. And you can see that there's not a lot we can do. You can set up containers, and you can set up multiple containers, but they all have to be kind of related, right? So I have this container, it's running. This is the image that it came from. It's just a hello world container, and it kind of tells you what it does. So this is really good, like I said, if you're doing a recurring process, just something that needs to sit there and run. You have a process that needs to go, I don't know, process orders once an hour, or delete users out of your Entra ID just for fun, just to keep people on their toes. Something like that, you'd put that into an Azure container instance, right? You can see there's no scaling at all. In fact, there's very little. This is all there is in the Azure container instance portal. There's just not a lot there. You can add an identity, and we'll definitely talk about identities someday because those are super important. You can set up some properties. I mean, you can look at the logs. There's just not a lot that you can do in an Azure container instance. Okay, so we're not going to waste any time on that. We're going to move on. The next thing we have is our container apps environment. So this is what I was talking about with the Azure container apps. You have a container apps environment which contains all of your Azure container apps. So if we go in here and we look at our apps, I have two apps running inside of the Azure Container Apps environment. I have a web app and I have my services app, okay? And we can go into the web app and we can, now if we go look at the revisions, so with Azure Container Apps, you can have multiple revisions also. So if you want to, now if you test in production, one thing you may want to do is do what's called canary deployments or A/B deployments, or there's another word for them. But anyway, so you may want to deploy your new stuff, but only let 10% of the people use that new one, right? Just so that you can make sure that it's going to work before you have to roll back and go back to the old one, right? So with canary deployments, with Azure Container Apps, you can do that. You can also do that with Azure Web Apps. But you would come in here and you would create multiple replicas, and then you would deploy to the different replicas and specify the percent of traffic that you want to go to a specific replica. And as you verify that it's okay, 10%, no complaints, let's push it to 20%. Okay, it ran for a little while, no complaints, let's push it up. Let's push it up until you get to 100%, and then you can get rid of the old replica.
How would you handle this with database migrations? Let's say you're changing the migrations.
Well, it depends. If you have a migration that has a breaking change, then you would not do this, right? And typically, if at all possible, you try to make your databases not have breaking changes, right? A couple ways that you do that is you use Entity Framework, right? And you make sure that you don't delete properties out of your entities and then do a migration. You don't want to remove anything. You can add stuff. So you just need to be kind of careful about not introducing breaking changes so that your old replica can still use the old Entity Framework models without breaking anything. So you just got to be careful of that. But if you have breaking changes, then you can't. So with migrations, you can back out a migration, right? Or you can back up the database. The problem is that if you do a migration that like adds a column, then when you restore the database, you're losing that column, right? So the best way to do it, honestly, is just to really try not to have breaking changes. And that might be hard. You may end up with data that you don't need. I've got to get rid of this column because I don't need that data anymore. Well, you can do that maybe down the line a little bit when that instance or that revision of your app is completely gone and not in use anymore, right? Then you can, but then what you do is you write a migration to do that for you, so that if you do need to go back, you can go back to the way it was. Right? That's one of the beauties of migrations, is you can put them in your pipeline, and then you can have it go forward, but you can also have them go back if you need to. You can revert back to an older migration. That's why if you ever look in the code, you have the up and the down, right? The up applies the migration. The down will back that out to the way it was before. Okay. Any other questions on this piece? No? Okay, so if we go into the overview tab and we click on this, let's go look at that for a second. This right here is the URL to that website. And it looks awesome, doesn't it? Isn't that what you want your customers to go to? That's good stuff. Actually, you can hook up custom domains, so you can have it be whatever you want at yourdomain.com, right? But this is the one that Azure assigns to it, and this one will always be there. Even if you had a custom domain, this one is always there if you want to use that. But if we go over here, you can see, boom, there's my website. Isn't that awesome? Yeah, so this is, and we'll talk about this here in just a second too. Okay, so in your container app, you've got, so here's the containers. So you can see the image that we're using. I'm getting it from Azure Container Registry. It's this image, that tag. You can come in here and you can manually update the image if you want. Typically, I like to do it through a CI/CD pipeline so that you don't have to do any of this. Along with, you can also set the scaling. So you can see the scale here. My min replicas is set to 0 and my max is set to 4. That should also be done inside of your pipeline, right? So that you can set your dev to 0, but have your pipeline automatically set your staging to 1, set your production to whatever you want that minimum to be. So since this is 0, it's going to scale to 0, and it's not going to charge me while it's scaled down. And I'm using an HTTP scaler. You can come into here and you can change this to be a Azure Q or a custom scaler. These uses the Keta scaling rules that AKS uses, or that Kubernetes uses. So let's see. You can set up volumes so that you can, I mean, one of the problems with containers, right? If you save data in your container, what's going to happen next time that container restarts? Your data's gone, right? So you set up external volumes, and that's where you save your data to. So you set up these volumes to point to an Azure Storage Files account, and then it's put all your data there. And then when you restart the container, that's where it's going to read the data from. So if you're using like a MySQL database inside of your container, you want that MySQL database to be saved on an Azure file store, not inside the container itself. I actually made that mistake once. Not good. Your whole database is gone. So we also have the authentication. So a lot of times you want people to have to log in to your app, right? There's a couple ways to do that. You can do that all in code, where, so like in .NET, you put in the authentication middleware, right? You point it to your OpenID backend, all of that stuff. With Azure Container Apps, you can actually set authentication at the perimeter level, irrespective of your code. So your code can be written in anything you want. You set up authentication at the perimeter level, here at the container level, and then when anybody comes into that container, it will redirect them to whatever authentication you've set up. So you can see here, I set up the Microsoft authentication to go to my Entra ID. You can also set up, you can set up to use Apple. You can set it up to use Google, GitHub, Facebook. You can set it up to use authentication from any of these areas that you want, right? There are some drawbacks to it. You don't have as much control over the token that you get back, right? So there are some reasons to do it in code, but if you just need a quick and dirty way to provide authentication on the front end, this is a good way to do it. So you'll notice that it went right into this because I'm already logged into my browser with my Microsoft account. It detected that, so it logged me into the website. But what it does is it passes some of that login information through your headers for your HTTP request. So you see these down here at the bottom. My principal name, that's the username that I'm using to log into my, my browser. My principal ID, the type of principal it is, and so there's all kinds of information. If that's all you need, and you can customize that to pass in custom claims as well, but if that's all you need, then this might be a really good way to do authentication without having to wire up your app to do all of that, okay? And that also applies to Azure Web Apps. Most of the stuff we're talking about here applies to Azure web apps as well. You can do this authentication front end. And what it does, if anybody cares, is it actually installs a sidecar into your container. So it's a separate container called a sidecar that captures the incoming request, and then it takes care of all the stuff, and then it passes that HTTP request onto your application with those added headers. Okay. So if you come into monitoring and you go into log stream, so this is a place where you can go. Oh wait, okay, sorry. I need to go into the app. So if we go into the web app and then go into log stream, so this is where you can go to see all the logs of what's going off. So if you're doing, like in .NET, if you're doing your logger.log information or log error or whatever, it's going to show up in this stream right here, along with log analytics. And we'll talk about App Insights and Log Analytics another day. But you can see that we have two containers here. We have the HTTP auth and the web app. This HTTP auth is the sidecar, so you can look at the logs for that sidecar. Okay. We have identity. Here's the Dapper. So we're not going into Dapper today. I know that we're already at time. Dapper's huge. It's really cool. If you want to use Dapper, you're going to definitely want to come to our Dapper presentation probably sometime early next year. It's very cool. You can put secrets in here. So everybody knows you don't put secrets in plain text, right? So you can put them in here, and you can reference Key Vault directly from here so that your applications don't have to even know that Key Vault is a thing. All it does is it asks for the secret from the container app, and it gets it. It doesn't know where it came from or what it is. But then nobody can see it in here. Yep, that's what goes in here as your environment variables. Yeah, and you should, if you're running in Azure, you should never. Well, I won't say never. You should rarely have to use the Key Vault SDK to get your stuff. You should this is my opinion, I could be wrong. You should always do it from environment variables. And I'll show you a way in an Azure web app to do that as well. So we'll show you when we get there, but you can specify, hey, this environment variable needs to come from Key Vault. You never see the value at all. And then your code, if you're using C#, it's environment.getEnvironment variable. You just pass the name of an environment variable. It will resolve the Key Vault value and return you the Key Vault value without you ever even knowing what it is. It's really cool. And we can show you that in no time. But, all right, so I mean, there's a lot of stuff in here. You can see that there's a lot more than there was in Azure Container Instances. So let's move on, because I don't want to. We're going to have to hurry now. And I know that 7 o'clock is technically when it ends. If you have to go, I won't be too sad if you get up and walk out. I'll just be a little bit sad. So here we have an Azure function. So in an Azure function app, you can have multiple functions that run in there, right? So in your .NET code, you would have a function project, and then you can have multiple function apps inside of there. I only have one in here called function one because my naming skills are what are they, mad skills? Is that what they say these days? I have mad naming skills. But you can see this is an HTTP triggered function. It's enabled. And essentially, it's like I said, this just runs these short little things. You can have timer triggers that go off every 5 minutes. You can have service bus triggers that respond to messages being put in the service bus. All kinds of stuff. Again, functions is another whole week of presentations. Here you can put it into so they all have an app service plan. By default, they're consumption-based, but you can put them into an app service plan that's not consumption-based. And they actually now have this flex consumption model where, because a consumption-based function app doesn't have any capability of having, thanks Jess, of having any virtual network integration, right? So if you need your function apps to be in a virtual network and have all of that capability, you need to either put it into an app service plan, or you need to put it into a flex consumption is what it's called. You don't get the price cuts, right? Obviously, it's going to be more expensive when you do that, but those are options. Let's see, is there anything else cool to show about functions? We have the log stream, so you can watch the logs of those. Also, now with these ones, though, you need to set up application insights before you get any log stream. So if you have an Azure function and somebody comes to you and say, hey, man, this thing's cratering, what's going on? You go look and you get this screen, you're like, oh, crap. I forgot to set that up, right? Because you can't get the stuff that's already happened. Once you turn on application insights, it'll be from that point forward. So, but application insights is its own problem. If you gather too much data, it could get really expensive. And so you got to kind of, pick your battles on that one. So these are our different ways we can call the function. So you use an app key. So when you call the HTTP function, you would pass in a key in the query string or in the header, and that's how you would keep it secure. You don't tell everybody your key. You can hook it up to API management. We didn't talk about API management. That's, again, a talk for another day. You can set up cores. You can set up all kinds of stuff. So any questions on Azure Functions? Everybody knows everything about them now? That's good. Good to hear. Okay, let's just look at what else do I have in here? Here's my log analytics workspace. Oh, I've got a SQL Server in there. Okay, here's a web app. So this is an Azure web app. And so Azure web apps, again, when you set them up into an app service plan. This one is set up into the F1, which is the free tier. Again, there's a lot of downsides to that, right? But for demos like this, I don't want to pay for it, so I put it in the free tier. You can do Linux or Windows in Azure web apps. Again, if you're doing .NET Core or above, then Linux is usually the better way to go because it's cheaper. So if you host the exact same application in a Windows web app versus a Linux web app, the Linux web app is probably going to be 30 to 40% cheaper. And so it's a good way to go, and it runs exactly the same, right? So there's no downsides. There are things that you need Windows for, and in that case, you can do it in a Windows one. Because Linux is free, I guess.
You actually pay for the licensing. Windows licensing is more.
Yeah, well, exactly. So, and even though it's Microsoft and it's their own stuff, I don't know. But, in fact, I've heard that like 80% of workloads running in Azure are on Linux. And so, again, which 10 years ago, dude, I would never have believed that. Yeah, oh yeah, I was IIS from long back, right? But now, honestly, I don't even know how to spell IIS anymore. I haven't looked at it for so long, and I hope I never have to look at it again, to be honest with you. Are there versions? Are they still around? I don't even know. So here is where you would scale it up. So you can scale up. Now, this is to scale. You can't do auto scaling with the free tier, right? So you'd have to scale up to one of the production tiers. I don't even think you can auto scale. Oh yeah, okay. You can scale these other ones, but they don't auto scale. So you'd have to manually scale it. So scaling up is giving it a bigger computer. So think about, you've got your Raspberry Pi. Scaling up would be putting it on a big gaming computer with a big video card, right? That's scaling up. You're giving it more horsepower to run your workload. Then scaling out over here is giving it more instances. Now, if you're going to be scaling out your web app, like we talked about before, you need to make sure that your web app can handle running in different instances, right? So you may have to have a Redis backplane for your caching. You may, whatever you need to do. And you can set up sticky sessions in Azure Web Apps so that if a client comes into instance 6, then next time they come in, they'll go to instance 6. Every time they come in from that point, they'll go to instance 6. Now, there is one problem with that, is if it scales down to 5 instances, well, there's no instance 6 anymore. So it's going to go to a different instance. So if you were counting on keeping your state inside of the Azure Web App, they're going to lose their state, right? Now, you probably shouldn't be keeping state anyway. So you don't auto scale up. Scaling up, you don't auto scale. Scaling up, you set it and to what you think you're going to need, and that's where it stays. Scaling out is what you can auto scale. And I don't think, so it's not even going to let me really show you how to do that because I'm in the free tier, so it's not even an option. But you could come in here, you can do manual, automatic, or rules-based. And so you have really fine-grained control over how you scale this thing out. You can also put Azure Web Apps into an Azure Service environment, which gives you a lot more robustness, a lot more power. We won't talk about that today either. Rather than have an Azure Service or App Service Plan, you can put an App Service environment, and we'll go over that another time as well. This is kind of cool. This is fairly new, load testing. You can put in load testing rules and have it hit your website with 50,000 requests to see how it handles load. So that's kind of a cool feature. It uses, what's the super popular load testing framework? Well, if nobody else knows, it's called Bob. Okay, so there's this really powerful, I can't remember what it's called, but anyway, so it does load testing like that. It's really cool. And then you can get into the SSH. You can set up API management for that as well. So there's a lot that you can do there. And then one last thing I want to show you is the storage account web app. So if we go into, you know what? Never mind, I didn't set one up. Oh, oh no, okay, sorry. This is the, so when you create an Azure function, it has to have a backing storage account, so it creates one. So that's what this is for. But what you would do, actually we could do it in here, it's just a storage account. You could come into here and go into settings, or not settings, where is it? Crap, maybe I can't do it on this kind of storage account. Let me see. The static website. Okay, hold on. I can actually, let me go show you a real one that I use, just to show you how that works. It is going to be in, where is it going to be? I can't even remember. Let's see. Maybe I, oh, well, here's one. Let's see if we can set it up in here, just for fun. So right here, static website. Okay, you see I've already got it enabled. So typically this is going to be disabled. If you click on enabled, it'll give you the primary endpoint. So this is the URL for that static website. You also give it a document name, and then you give it an error document name. And then what it does is it will create this new container called $web. And anything that you want in that website is going to be in this $web. So if we go back into here and we go into our static website again, and we're going to copy this guy. We're going to come over here. We're going to paste that in there, and then we're going to say, good grief. And there's the website that's being served up from that storage account. Again, totally static site. You can come in here and you can see we've got this. This is what it generates from that stuff I mentioned earlier. So it generates all of this stuff for the architecture for your system. And this, so I've got a pipeline that's set up. It just dumps this stuff into that storage account. Super cheap, super easy way to serve up static content.
Does this have a deploy step, or is it more just like a Google Drive?
You could actually absolutely just throw it in there. If you can use AZ copy, you can use Azure Storage Account browser. What's that? Yeah, absolutely. I mean, anything that you can, this is just an Azure storage container. You can actually even map a drive from Windows to here and then copy files directly in your Windows Explorer if you want to do that. I like doing a pipeline because then it automatically builds it when I shove it up there. But and this has to be public, right? I mean, so you don't want to put super important stuff in here because it's, I mean, you could make it private, I guess. But all right, any questions on that? Any other questions? Any questions on anything so far? I say so far because we're done. Oh, yeah, shoot.
It's very weird. And that's a while ago. On your terminal, has colors that I've never seen before.
Yeah.
Get that style.
It's a plugin called Oh My Posh. Oh My Posh. Just Google "Oh My Posh" and you can configure absolutely everything about the way that your terminal looks. So you can see here, this is the user. I've got the folder that I'm in. This is the branch. So if you're using Git, it'll show what branch you're in. This is some other stuff. And then you can put like Azure stuff. You can put, and there's like 100 different built-in themes that you can pick from. Yeah, so Scott Hanselman has his setup. So he has a patch because he's diabetic. He has a patch that communicates with his phone to show what his blood sugar level is. So on his command line, he has his live blood sugar level at all times. So it's kind of cool. And if you use command line a lot, which I do, it's really cool. All right, so these are the things we didn't talk about. Service Fabric. We also have a bunch of no-code, low-code options. We have Logic Apps. We have Power Platform, right? We have all that kind of stuff. We didn't go into that because technically you're not hosting apps. You're building, whatever. So there's a lot of different ways to do stuff in Azure. Okay, that's all I had. If there's no more questions, thank you so much for coming. We had a great turnout tonight. I appreciate it. Yeah.
I got one question. It's
Shoot.
a little bit disconnected, but it does storage accounts. Is there a good method of making multiple API requests to download files, individual files, storage?
So you want to download them to your machine?
Yeah, or just a web server. Because my understanding is to get each individual file, there's not like a full container.
So probably the best way to do it is through AZ Copy.
What?
AZ Copy. So it's a utility that you have to install. You don't actually install it. It's a standalone executable, but wherever you put it, you want to put that folder in your path. AZ Copy is super powerful, super good way to move files in and out of Azure storage.
The question is, are you moving the files to a web server, or are you trying to get files from a web server?
It doesn't matter. AZ Copy can do it all.
Well, if it's an external client, they don't have access to Azure.
So what you would have to do in that case, so if you're needing somebody else to get access to your storage account, then you would have to create what's called a SAS token. And SAS tokens can be really granular in what permissions you give to allow people to access your storage account. You can even limit it to a single IP address. And then what they do is it creates, well, I can show you, it creates a connection string.
You can like create a container inside of here, and then customer as a container.
Yeah.
Based off their tenant ID.
Yeah.
Stored in the data.
So how do they not get access to other people's containers?
We have,
Is it RBAC controlled?
it's per API, the service per API call getting the block container.
So they call the API that goes to the container. So technically that API could go to a different container, but based on their tenant ID, it knows which one to go to.
Yeah.
Okay.
That ID is inside of the data.
Gotcha. Okay. Yeah, that's probably fine. What's the API running in? Is it an Azure function?
It's a C# app. Or not.
Running in an app service?
App service. Yeah.
So it's an app service. They call the API, pass in the JOT token, or I guess JOT, because, yeah, anyway. They pass in the JWT that has the tenant ID that you use to get it from the thing. Yeah, that's probably fine as long as you have your blob container not visible to the outside, right? And you may actually want to set a private endpoint to your storage container so that only things inside of Azure can get to it, right? Private endpoints are a super secure way to make sure that nobody from the outside can ever get into it. Okay, that's fine for authentication and authorization, but setting up a private link is a network layer level thing so that it's isolated to only those. So then only things that have access to that private link can even get to it at all. That's different. That's a little different. So private link is something that you have to set up intentionally, but it's really good. It's a really good thing because that way you're making sure that, and then when you set up a private link, everything goes over the Microsoft backbone. Sometimes if you don't set up a private link, things could potentially go over the open internet to get between resources. You don't want that. You want things going over the Microsoft backbone. Private links will ensure that. And so that's a whole nother discussion on Azure networking, which is a whole other thing. So yeah. A lightning talk. I don't know. Lightning talk might not be, but and Azure networking is something else we're going to be doing. You could, but probably what you'd want to do. So you've got the API that needs to get those out. So you got your Azure web app that needs to copy the files. Where are they copying the files to? Down to the customers?
Yeah, it's
Zipped and sent back. So AZ copy wouldn't be the way to go for that then. Out. You're done. Only one tenant at a time, probably though, right?
It takes one request per file to download, right? Are you doing it? Are you saying, okay, this file's downloaded, then I'll start the next one, or you start like a bunch of them?
It uses a wait inside of the for loop. I think
That's one of the times.
Are you using the Azure Storage SDK?
Yes.
There should be a way to grab an entire container, but it's been a while since I've used the Azure Storage SDK, so I'd have to look at it again.
A lot of solutions where you just set all the files you want and get that one sent back instead of getting each individual file. But that means if I want to add one file, I would have to close it down.
Oh, I see what you're saying. So they may only want a single file. Yeah, no, you wouldn't want to do that then. You don't want to give them more than they need for sure, because you do pay for egress on some things from Azure too, right? So if you're sending a bunch of stuff out that you don't need to send out, you may be paying extra money for the egress for that. But so I mean, let me think on that, and I'll think about that a little bit. I have to look into the SDK again, because if they pass you in a file name, you can go get that exact file, right? That single file, and just pass them back the file. You should be able to do that. But if you're doing tons of them, then you should zip them up and send them back as one. Yep. So if you have ever used Google Photos, if you go to download a single photo, it downloads the single photo. If you go to download 2 or more, it always will zip them and you download the zip. Right? And that might be a possibility as well. So that's where an Azure function. So you can have a storage triggered Azure function as well. Yeah. It does something to it. So if you see a new file show up in a container, you can then re-zip up all the files in that container, right? Automatically, just behind the scenes, it just does it. And so that would be a good use case for an Azure function there, unless it takes longer than 5 minutes to zip up all the files.
Right, that's the way to do that.
Yeah. Yeah. You could also make your storage account, you can expose files to the public, and then they can just download it directly from there. But that's where you'd want to use a SaaS token, and that may be more work than you want to make your clients do, right? So, yeah, I think maybe having an Azure function, zip them up and just keep them zipped, and then just download that one zip file would be a quick way to do it. If I think of something else, I'll
In terms of egress, it's for keep it.
Oh yeah.
File, and then size-wise, it's the smallest.
Yeah.
If you didn't zip them up, then you'd be doing, not only are you doing a bunch of files, 2,000 files, but the size of those files,
Yeah. Cool. Anything else?
Will you be doing talks on
let me tell you something. So, right before,
This was gonna be, I thought you were gonna show us 5 ways to automate it.
no, hosting, it said hosting. No, honestly though, so at the beginning of the summer break, I sent out a Google form to do a survey to see what people want me to do a presentation on. I am happy to present on whatever the community wants. So I'll be sending out another one of those. And if you get it, are all of you signed up on the Meetup site? If you're not,
What does that mean? I made a meetup account just to.
so what you need to do is you need to find the Salt Lake Azure Group and just join as a member. That's it. Yep. Because when I send out my emails, I send them out to the entire group. And so I'm going to send another survey out, and I'm going to put a list of things that I think people want to know, but there's always going to be an other on there. And so whatever you guys want me to present on, and it doesn't always have to be me. If any of you want to present, I'm more than happy to give the floor over to anybody. Seriously, I'm always looking for other presenters because nobody wants to listen to me all the time. But if I don't have another presenter, I'm more than happy to present. So. But I'm going to send out a survey. Let me know what you want, and I will present on anything Azure, Azure DevOps. We could even dabble in .NET, how to use .NET for Azure, stuff like that. More than happy to do whatever you need. Entity Framework, I could do Entity Framework. Yeah. Entity Framework's pretty awesome, and the thing about Entity Framework is a lot of people don't use it right. You know, what's that? I love Entity Framework. And in the early days, they had performance issues, right? But man, I tell you, EF8 and EF9, I think it's better than Dapper in a lot of cases. Yeah. And Entity Framework is just slick. I remember the days when I had to put SQL strings in my code. I don't know if any of you have ever done that, but it's brutal. There's a thing called SQL injection. That's where it started, that kind of code. So. Yeah. I used to be a big advocate of stored procedures. I used to preach stored procedures, but they may have their place still. But man, I have seen multi-thousand line stored procedures, and it is horrible. Anyway. All right, well, I'm going to stop presenting. If you want to stay behind or ask any questions or whatever, I'll be here. But otherwise, thank you for coming, and I appreciate your participation.
Has anyone presented on Copilot?
Not in this group. Mike did an AI presentation about customer analysis. What was it called, Mike?